And that's our final graph and our final domain and range written out. In these next few examples, we're given a picture and we want to find the actual equation to the graph. So let's start out with problem A. In problem A, we know we're going to have a y equals something. We'll have some kind of shape and an x somewhere. That's a good way to start. Now, the next thing that we should look at is the shape of the graph. The fact that this is half of a parabola on its side. The fact that it's this shape. Well, the only graph that has that shape is a square root graph. So we'll put a square root on our x. Well, also, the question is, which direction has this graph been shifted? Well, normally the center is at 0, 0, but it's been shifted to the left to -5. So it's been moved to the left 5 to -5. Remember, left and right always appears as reverse. So if you see a -5 or it's been moved to the left 5, it actually means you're going to have a +5. And remember, left or right has to deal with your x values, so that's going to be on the inside of your square root graph. So I'm actually going to have a +5 on the inside. Notice we didn't shift up or down, so I don't need to include any other numbers with this. Another thing that you guys talked about back in college algebra as a review is increasing or decreasing. When you're determining increasing and decreasing, you should be reading your graph from left to right. So when we're looking at increasing and decreasing, we're going to read our graphs from left to right, which means that we're going to look at x values like we do with the domain. Okay. Well, if we look at our graph from left to right and trace it, our graph is always going up, which means we're always increasing. We are never decreasing on this one. Where does it start? Well, going left to right, it starts where the graph starts here at -5 and does continue off to the right forever towards positive infinity. So far, so good. The question is, what do you put at -5? We always use open intervals when we are increasing or decreasing, and what open intervals means you should always be using parentheses, not brackets. So we're going to use a parentheses here because they're going to tell us to always use open intervals. The other idea of kind of the reason why you use parentheses is because if you were to try to use brackets, what would end up happening is at some values you would end up having it included in increasing and decreasing. And that doesn't really make sense to have a value that's increasing and decreasing. If you kind of think of that as like an analogy of a car, you can't have your car going forwards and backwards at the same time. It's not possible. So we kind of call those transition points, and we kind of don't include them at all. Okay, let's take a look at problem B. In problem B, let's take a look at its writing an equation first. Well, notice we've got the U shape, which means we've got a parabola shape, which means we should have something squared. So we've got a y equals, we'll have an x, and we'll have the x squared. That will get us the U shape that we want, is if we square that x. Now the question is, which way has it been shifted? Well, normally the center is at 0, 0. It's down here though, which means at the very least it's been shifted to the right 2. Remember, with left and right, it's always reverse of what you think. So even though you're shifting to the right to a positive 2, you're actually going to see a -2. And remember, x values go inside of a function, so I'm going to have a -2 on the inside with the squared. Now the question is, how much has it been shifted up or down? Well, notice it's been shifted down to, let's see, what is that? It's a -3. So remember, up or down gets put on the outside of the whatever it is, in this case a squared, and it's exactly what you would think. So because you went down to -3, you're going to put a -3 on the outside. But that's it. Now this one's a little bit different with the increasing and decreasing, because part of the graph is increasing, part of the graph is decreasing. Which one's which, though? Well, if you take a look at the graph and you trace it from left to right, well, if I trace it from left to right, the first half that I've just traced is when I'm decreasing. I'm going down from left to right. So that portion of my graph where I am decreasing is starting on the left side, which is -infinity, comma, be careful, left to right means I'm stopping at what x value? A 2. Be careful not to use the -3, it's a y value. We're always reading from left to right if we can, which is domain. We're never going to be using the y values unless you're specifically asked for the range. So decreasing, we'll use -infinity, which always has a parentheses. We're always using open intervals for increasing or decreasing, so we'll always use a parentheses. The other side of our graph, though, if you trace it from left to right, is going up, meaning it's increasing. So if I wanted to write out that increasing, well, it started at the same value here from left to right, that's a 2, and then continues on forever, so to +infinity. Again, we're going to use open intervals, meaning we'll use a parentheses on the increasing side, and we are done. Last one, let's take a look at problem C. In problem C, we've got a V-shaped graph, which means we've got a absolute value graph, which means when I go to write my equation, I should have a y equals an x and an absolute value bar around the x. The question is, where has it been shifted from, and where is it now? Well, it normally starts and has a center on its V at something like this, 0, 0. Well, that means it's been shifted to the left 2, but then it's also been shifted down 1. So the left 2 means you went to +2, actually means you should have a -2. Again, with x values, it goes on the inside, so a -2 goes on the inside. But then you went down 1, which means I should have a -1 on the outside. However, this one looks a little bit different because there's something called a stretch, and we'll learn more about this later. But there is a stretch, meaning there's a number that should be out in front. We'll call that a number out in front. If you want to find that A, though, what you need to do is pick out another point from the graph. The easiest point on this graph to pick out is that our graph still does go through the point 0, 0, and plug that into our equation to figure out what does A end up being. So you would take your y equals A times the absolute value of x minus 2 minus 1, and you'd plug in your point that we just came up with, the 0 for y and 0 for x. And what that would give you then is 0 equals A times the absolute value here of 0 minus 2 would give us -2. And then you'd say, oh, well, yay, the absolute value of -2 is actually going to be a +2. So that would still give me 0 equals 2 times A, but this would be a +2 once you take the absolute value, -1. Solve it like a normal equation means you'd add 1 to both sides. And what that would do is, let's see, continuing along would give us 1 equals 2A, and then we can divide both sides by a 2. And that would give me that A equals 1/2. And then you could go plug that back in. So you take your a equals 1/2 and plug that back in for a, which would give us our final equation of y equals 1/2, absolute value of x minus 2. And then don't forget there was a minus 1 on the outside, and that would be our final equation. And that number out in front is called your stretch. We're going to learn more about that later, but it is something you were supposed to have seen when you took college algebra, which was a required prereq to this course. For increasing and decreasing, let's talk about decreasing first, because that's what we're going to do first. If you trace your graph from left to right, what you should notice is from left to right, you're going down first. So what will that look like for your decreasing interval? For decreasing, it'll look like negative infinity to where you stop here at 2, because you're reading it from left to right. Just like before, you got to use an open interval, so you'd stop there with a parentheses of 2. Then for increasing, you'd go from left to right again. That's the right side of the V, because you're going up. Would start at 2 and continue forever towards positive infinity, but you'd be done there. That gets you your equation, and also when you're increasing and decreasing. But what this problem does is leads us into, what if you have a number out in front that stretches or shrinks our graph?